Okay, now, so what I did was I spun the two more HELIXs around here. So the first HELIX have iron wire spun through there. The second HELIX have an iron wire right here. This is the second HELIX that rises from here to here, and it has iron wire there. So iron wire on the base. The base is the coil, and the iron wire is underneath there. So this base lattice goes directly up. Then the following ones that follow along here, which is iron wire, steel wire. And what I did was I spun like a pancake, similar to like a spiral coil, and I had it going around here. It turns around here. It goes up here, follows back around here, goes around and around and around, as if a pancake coil. So the pancake coil is dealing with two phase wires, as you notice. Phase wire is coupled together like PVC, and I'm phasing these two different sides so that one will be pushed and one will be pulled solenoid. So, like I said, this is aluminum cylindrical, which causes this actually to escape upward, and this coil will actually pull and push to a fixed position vertically in space, so that it has a sort of a self-balancing. So this is the ear gap right here, as you see right here and right here, and this one big ear gap, but it's always perfectly circular, but it's an ear gap. And that fluxes the density of the aluminum in the central, pulling and pushing, because there's two phase wires. The phase wires are together. So one will be pulled and one will be pushed, the whole vector. And that will repel the aluminum that is going to receive a flux of a DC flux of voltage. And it will give off its own field at the same time that the coils will give off a field to it, having iron wire to increase the flux of the field and the force of the electrodynamic force. Now the following is the respironics that I'm going to add at the bottom. I have a mount here that I'm going to place a cup like over the back, and this should be an aluminum cup that bears the modules all around it, which will actually modulate the voltage. Just dealing with rectifiers, oscillators, controllers for the PIR sensors, and MCU chip for vertical stabilization and self-balancing into the air. Now, the top part, where it has a cup that goes over it, that has a cone nozzle. The nozzle is an internal cone, just like an indented cone. And around the rim of the indented cone shall be holes to where the ion gus, when applying the copper cylindrical, hollow cylindrical in here, that it fit alongside the walls. And then the following cylindrical, which is graphite cylindrical, that is hollow, that is also going to fit alongside the copper. Now, the graphite will create me a shield so that the electrostatic will flow through, and just like a plasma torch, and it will move through the walls and try to repel from the walls because of the aluminum and the copper that is being loaded together. That's DC flux. And it emits an AC flux and causes like a solenoid coil air gap. So this is going to be like the solenoid coil air gap that causes thrust to flow out. Now the thrust is going to flow through the cup that I have with holes in it. The holes are going to be arranged alongside on the top part of the cup, alongside in a series like a donut. And these are going to be bleeders to bleed to force the plasma to remain vertically and not bend and pitch on axis or turn. While the object, the wand, is turning the handle, it would not flex the flame left or right. However, the flame will remain straight because the walls, it will operate as a gate to protect the flame, to protect me and also the plasma from bending. Two, it's to go like a plasma flame, like a Tesla candle, like plasma flame. So those modules will be added to it along with a respironics module that will actually create the oxygen gas and pass it through the system. I will convert the oxygen gas into argon gas, which will allow the electrons to actually pass through with extraordinary color, brilliance, and force in electrodynamics. However, the pressure that I'm going to use, the air pressure of the ions, are going to also push against the plasma to hold it in proximity, like I said. And I'm also going to use gyroscopic sensors. I'm also going to use PRR sensors as far as rangefinder switches, rangefinder laser switches. And that's going to deal with when I put my hand in local to the blade or local to the force, it will shut it off and cause the plasma to decrease. It would shut it off. So going in an angular towards it would actually shut it off. So anytime this was a full, or I was to move it towards my face or my arm, it would immediately shut off and shut back on. So that's going to be a switch to protect me and my body from this saber, lightsaber. And this is going to be like similar to the original one. So the idea of self-balancing into the air, and also using smaller coils, because I plan to add smaller coils with wafers of aluminum alongside, with coupled to a copper wafer. And these thick two pieces, probably 1/8 of an inch or 3 millimeters, should be coupled together with these two materials, and they should have a copper coil alongside. And I'm also going to phase the aluminum with a DC, so I can force the self-balancing proximity by pulsing every time it pitches on axis. This sort of configuration will enable me to do organizing tricks with the sword, twisting it in the air and catching it, and doing different tricks that they do in the movie. So my name is Jermaine Morton, and I'll get back to finish with this tomorrow. So goodbye.